All right. Can folks hear me? I don't know if I muted myself by accident. Yes. Okay. All right, cool. Thank you. All right. So yesterday we finished the lesson by talking about higher order derivatives. And so this idea that we can find one derivative, which we typically call the first derivative, but then we can sort of continue that process and find a second and a third derivative. And actually, when we talk about particle motion in 3.4, we'll come back to this idea of first, second, third derivatives and talk about sort of some real life applications of when we might use those different derivatives, okay? And for today, what we're going to do to get started is we are going to take a look at some special slopes, all right? And so one of the things that I think is extremely tricky about calculus is there's so many different ways for me to ask you to find the same thing. And so one of the goals of today is to start to unpack what are all of those different ways of asking things so that when we read a problem, we can actually interpret it and connect it to whatever strategy might be helpful, okay? So I'm wondering if we can start with a little bit of a mini what do we know, okay? So things that we know about lines. And in particular, what does it mean to have a line where the slope is horizontal? What can you tell me about a line that is horizontal in terms of its slope?
Its first derivative is 0.
Its first derivative is 0, exactly. And so I see in the chat that some folks are saying a horizontal line has m equals 0, right? And so m standing for slope. But I think that it is also really valid what Jeremy is saying, that we have y prime equals 0, right? Those two, and actually maybe instead of a comma, because they're not separate, they are actually equivalent statements. So if we say the slope is 0, what we're really saying is y prime is also 0, okay? And that right there is a really important connection I want us to make. We're going to use that a lot. We're going to be looking at special cases where we have horizontal lines. And so what I really want us to connect that to is not just that they're horizontal, but in particular that y prime, that first derivative, is equal to 0. Okay. Now, in contrast, I'm wondering if we can say some things about a vertical line. What do we know about a vertical line and the slope of that? All right, what might be a better way to phrase no slope? Yeah, I think if we modify no slope and change it to undefined slope, I think that's actually a more accurate way of describing that. Okay, so we can say m here is undefined. And if we use the same idea as we did before, m equals 0 means y prime equals 0. If we say m is undefined, we're really saying y prime is undefined, okay? So we have 0 and we have undefined. And before we move any further, let's do a very quick review on how we get 0 and how we get undefined. So let's say I had 0 over 1. What would you tell me that that equals? Now, generalize this for me. If I have a fraction, how can I guarantee that I'm going to get 0 as what the fraction is equal to? Okay, so we have sort of, yes, okay. So anytime we have 0 in the numerator, okay? So when we're talking about horizontal lines, if there is a fraction it must be 0 over some number. Okay, so if we get a slope of 0 and somehow that came from a fraction, it means that our numerator must be 0, or we have to have 0 on the top of that fraction. Okay. Now, similarly, I could have said, what is this? 1 over 0. And what do we get when we do 1 divided by 0? And so if I'm looking for a vertical or undefined slope, if we write a similar statement, if there is a fraction, it must be a number over 0. Okay, so we're looking for two different things. If we have a horizontal line, we want that numerator to be 0. And that's how we get a y prime of 0 or an slope of 0. But in contrast, if we have a vertical line, we want to have the 0 on the bottom if we have a fraction so that we can get that undefined piece out. Okay. Just a little reminder of which way we have to have the 0 in order to get 0 or undefined out of a fraction. All right. All right. Well, tell me what it means then separately for, let's say now we have 2 lines. And let's say that we have 2 lines that are parallel to each other. What does that mean in terms of their slopes? So let's say we have m sub 1. That would be the slope of one line. We could say that that has to be equal to the slope of the second line when we have 2 lines that are parallel to each other. Okay, and maybe we call this L1 and L2. L1 and L2, they're just lines, but they have to have the same slope if they're going to be parallel. Okay. And also a throwback to some middle school mathematics, perhaps. Tell me about the slopes of lines that are perpendicular. All right, we see negative reciprocal. All right, so if I were to think about the slope, we could say that the slope of one line is going to be equal to the negative. And how do we write reciprocal? If I'm using symbols here, how am I going to denote a reciprocal? Good, 1 over m, so 1 over m2. Okay, and so if we flip the fraction and we change the sign, that will give us the slope of lines that are perpendicular to each other. Okay, and so I do want to make a special note here that this means change the sign of the first slope. Okay, so it's not that the second one is always negative, but they should have opposite signs. If one is positive, then the other slope is negative. But if the first slope is negative, the other one's going to be positive. Okay. All right, so little refresher on some important characteristics of slope. We've got horizontal versus vertical, parallel versus perpendicular, and now let's apply that to an example, a few examples, okay? So question 6 is a very typical sort of question, all right? It says, find the x coordinate of all points of the graph y equals x cubed plus 2x squared minus 4x plus 6, where the tangent line is horizontal, okay? Now, this would be a good example of maybe knowing a little bit about the shapes of graphs, all right? So we maybe look at this and we're like, hey, that's a cubic function, x cubed being the highest power. And if we were just to imagine what that might look like, it should be something similar to this shape, okay? Now, if we imagine this shape and we were to say, how many places is the tangent line horizontal? What would you say to that? How many places for a graph like this would there be a horizontal tangent? All right, I see one, I see two, one on each hump. Yeah, exactly. And so if we were to look sort of right at the top of this bump right here, we can see a horizontal tangent. Okay, so I think that's one place where that might happen. And then the second place would be maybe right down here at the bottom of the second hump. Okay, so we definitely have more than one. All right, we definitely have two. Do we have a third one? Is there a third place on this curve where the slope is equal to 0? No, I think it's just these two, okay? And so the ability to visualize this is going to be really important. All right, so we've got two, which means that if we solve this algebraically, we should end up with two answers, okay? And so if we want to think about what this is algebraically, we'll just kind of put our picture off to the side. I would say that a good first step might be to find y prime. All right, now why would I want to find y prime?
Y prime is the derivative, and if you find anywhere where the derivative is 0, that's where those spots are.
Exactly, exactly. So let's find that derivative, because once we find our derivative, because we're looking for horizontal slopes, we're going to set that equal to 0. Okay, so let's find our derivative. So we get y prime equals, all right, we're about a week in from learning derivatives. Go ahead and type that into the chat. What do you get when you take that derivative? Good, things look good so far. All right, all right. So this x cubed becomes 3x squared. Good. All right, it seems like we are all in agreement that this becomes 4x minus 4. What happened to that 6 at the end? It goes poof. Yeah, that's 6. All right, again, if it makes you feel better, as a reminder, you can write that plus 0. Okay, in your head, maybe it's important to say that the derivative of a constant is equal to 0. Okay, but I'll kind of leave that up to you. I won't require that you write that, but I just want it to be a reminder that it did, like, something happened to it. It didn't just go away for no reason, that there was, because we're looking at a constant slope, that goes to 0. Okay, so we find that first derivative. And then, depending on the question, that will tell us what we need to set this derivative equal to, okay? So we're going to set y prime equal to 0, since we are looking for horizontal tangents. Okay, so not just, yes, we're setting it equal to 0, but like, why are we doing it? Because we're looking for the horizontal tangents. And so we end up with 3x squared plus 4x minus 4 equals 0. And our last step, which is really, I think, just an overflow from the first step, we are going to solve for x. All right, so find y prime, set y prime equal to 0, solve for x. All right, and so here we see a really good example of exactly when we might need to factor, right? And specifically looking to factor when that first number is not 1, okay? And so when we factor this out, we'll end up with, let's do a little bit of this out loud. So I know that it's going to be 3x and x because that's the only way I can make 3x squared. And then I kind of have to play around with the other numbers. But I think it works out if we do a -2 and a +2. Right, -2 and a +2. And if you're using the quadratic formula, you're not going to get the right factors, okay? So it is so important that you can show me this factoring step and not just use quadratic formula, okay? The reason is we are looking to find out what the x values are, all right? And quadratic formula just tends to take a lot longer, and it doesn't always help us show this intermediate step about what the factors actually are, okay? But we can set each one equal to 0. We would get 3x minus 2 equals 0, or x plus 2 equals 0. Then we'll end up with x equals 2/3 or x equals -2, okay? And so what that means is that these two x values correspond to these two places where the slope is 0. We might even say, if we zoom back into this picture, that this has an x value of -2. And I don't know what the y value is, but that's okay. And this one has a x value of 2/3, comma, something for the y value. All right. So when we look for these coordinates, most of the time, we're going to be asking for the x coordinate. We don't need to find the y coordinate. We just want to find out where this happens along the x-axis. All right. So let me pause here for a moment. Do we have any questions so far about this particular example? Okay. So here's what we're going to do with example 7. We are going to practice setting things up and writing out the steps that we might need to solve this, but we're not actually going to solve it, okay? So it's going to be more an exercise in terms of, if I look at a question, can I interpret it so that I have the right steps and I know why I'm making those decisions, all right? So example 7, we have this different function, x to the 5/3 plus x to the 1/3. And the question A says, find the x coordinate of all points on the graph that are perpendicular to the line 2y plus x equals 7. Okay. And so I'm wondering if we were to set up sort of steps like we did previously, where we said find y prime, set y prime equal to 0, and solve for x, what might we want to write for this part A over here? Okay. And I'll give you folks a moment to kind of think about that, but let's just throw some ideas out in the chat. Even if we're not sure what order things might have to happen, maybe just putting in there what we need to find would actually be helpful. Okay.
Also, find the slope of the second one, of that second equation.
Okay, so we've got a couple pieces here. This line, we got to find a slope of. And Luca says setting it into 0. So before we set y prime equal to 0, but this time we want to set it to the negative reciprocal of the line that we're given. Okay, that is exactly right. That is exactly right. Okay, and so if we were to modify this, we might say our first step is to find y prime. Okay, good. So find y prime. We might actually want to call this a second step. I'll leave that up to you. Find the slope of line we are comparing it to. So in this case, that would be the slope of this line, okay? Set y prime equal, let's see, how do we write negative reciprocal? It'll be negative 1 over m, right? So negative 1 over m, good. And then we could say step 4 would be solve for x, right? So even though we're not solving this, we've sort of described for ourselves how would we would approach this problem, then maybe we should highlight here that the perpendicular part is what tells us y prime is equal to negative 1 over m, okay? Now, as a quick review, I have this 2y plus x equals 7. How do I find the slope of that line? Yeah, we want to put it into our y equals mx plus b form. And so if we do that right here, we might say 2y equals negative x plus 7. And then we would divide by 2, we'd get negative 1/2 x plus 7 over 2. Okay, and so that would be how we get our slope for step 2. So I know we're not solving this question, which sometimes like makes people feel nervous, but how do we feel about the thought process in terms of unpacking the question and thinking about how that ties in to the methods that we've learned so far? All right, I see 1 thumbs up. Okay. Friendly reminder, sometimes it can be very intimidating when everyone else is like, oh, this is going super well. And maybe you're like, I don't really know what's going on. You can always send me a message directly. Nobody else has to know. It's never too late in the semester to start that. But without that information, without people telling me, hey, I don't really know what's going on, then it makes me think, oh, everyone's got it, right? And so it's really important for you to help give me that feedback as well, even if you're kind of nervous about it. It's okay to ask those clarifying questions. We might get to them in the lecture. We might, chat about them outside of class time, but it is still important for your voice to be heard, okay? All right, so let's take a look at part B, okay? So part B says find the x coordinates of all the points on the graph that this is supposed to say that are on the graph that are parallel to the line 2y plus x equals 7. Now we're looking at the same function that we did above. Y equals x to the 5th 5/3 plus x to the 1/3. And I'd like you to take a moment, all right? And now this time I'm gonna ask that everyone send me a message directly, okay? So don't send it out to everyone, send it to me directly and tell me what would you change about what we did in part A? Okay, what would you change about what we did in part A? Good, I've got a couple answers so far. Excellent, and everything that folks have sent me so far are correct. That is excellent. Thank you for folks' honesty. I love that. Okay. Cool. Let's give folks maybe just another 30 seconds to send their guesses in. And while you're doing that, I'm going to go ahead and copy and paste this. One of the luxuries of technology these days. Okay. All right. So I appreciate folks who submitted answers. I appreciate folks who are like, I really don't know, because again, it is so important that I have a full picture of how we're doing as a class, not just how some folks are doing, okay? And I know that I'm asking you to think about things, and maybe your previous learning experience has been like, somebody just give me a formula and I just plug it into the formula, right? So lots of learning happening here. But things that stay the same, we're still going to be finding y prime. Okay, we're still going to be finding y prime. We're still going to find the slope of the line we're comparing it to. But notice earlier that we said, let's highlight the perpendicular. And that's how we knew that it was going to be y prime equals -1/n. But what do we say when things are parallel? I think that gives us different clues, all right? So parallel means that we don't want to set the slope to the negative reciprocal, but we exactly want to set it equal to the slope we found in the second step. And the reason for this is because parallel lines have the same slope, okay? Since parallel lines have the same slope, we're gonna take the derivative and we're gonna set it equal to the slope we found, okay? So for those of you who are like, I don't really know, if you send me just like a 1 if that makes sense right now, or -1 if it still doesn't make sense, all right? But we are changing just one thing, which is instead of negative reciprocal, we're setting it equal to the same slope. Okay, now I had a couple guesses about this, like how do we change this? And a few people said, let's set y prime equal to 0. Okay, a few people said, let's set y prime equal to 0. What could we change about the question so that someone would say in their process, set y prime equal to 0?
You could say you're finding x coordinates of all points on the graph that are parallel to the x-axis.
Ah, parallel to the x-axis. I like that. I like that. Okay, so let's write this down instead. All right, I'll put a little star here, that we set y prime equal to 0 when looking for lines parallel to the x-axis, or we also call that horizontal tangent. So it doesn't have anything to do with the factors. I know a lot of times we factor things and we set it equal to 0 and we solve, but that's more of depending on what y prime is, whereas setting it equal to a specific number actually goes back to the concept of what we're doing, okay? All right, so we will be having some questions like this on the quiz. You'll have a different function, okay? You'll have a different function here in where the numbers are going to work out a lot better than this particular example, okay? So that's why I wanted to write down these steps, because you can use these steps as you look at the question on the quiz, okay? And so when you're taking your y prime, it would just be really important that you are taking the right derivative using the rules that you have, okay? And maybe if we think about what these rules are here, okay? If we were to take this derivative, we would just use the power rule and the power rule again, okay? Okay. Let's see, we have a question, we're supposed to set equal 0 unless the tangent line is horizontal. Exactly. So that's why I wrote this separately, that as a different what if situation, if the question says, find where the tangent line is parallel to the x-axis or where it's a horizontal tangent, then you would set it equal to 0. This is a separate question. This is like a what if. Yeah, that's okay. That's okay. All right. Now, folks, if you've listened to our last piece of discussion and it's still sounding really, really confusing for you, that's a really good sign that you should say, hey, Judy, can we meet up? I'm having some trouble understanding some things, okay? The not so effective response would be like, oh, I don't understand this. I guess I'll just keep working on it on my own by myself. Okay, that's like maybe a not very efficient response. But if you're sitting here saying all of this still doesn't make sense, that is a great indicator that you should come hang out with me and we should do some work together. Okay. All right, let us go ahead and finish up this last section here, okay? So in this last section, we're gonna be talking about something called tangent lines and normal lines, all right? Now, we've spent a lot of time talking about tangent lines, but now we're actually gonna practice the process of how we write equations for those, okay? And so we're going to start off with this function, y equals x squared minus 4x plus 6. And you are welcome to use Desmos to graph the function. And if anyone has any general descriptions, like what this curve might look like, go ahead and put that into the chat. And we can sketch a diagram without being too accurate right now, okay? Yep, I agree. It's going to be an upward parabola. Okay. Now, if you are sketching things on an exam or I ask you what shape, it is sufficient to say it's a parabola. Okay. But on exams, I'm asking you to not use Desmos. So if you draw a very accurate graph here, it's sort of a giveaway that you used the technology you weren't supposed to use. Okay. So you don't have to draw the picture. I'm just asking you what general shape it is. You can just say it's an upward facing parabola, and we should end up with something that looks kind of like this. okay? That is not the world's best parabola, but we'll imagine that it is such at this moment. And let's take a look at part B. So part B says, find the slope of the function at x equals 1. And so if you were to describe to me in sort of steps how I might approach this, what would you tell me to do in order to find the slope of the function at x equals 1? Ooh, all right. Find the derivative. Ooh, okay, okay. So let's be really careful about our language here, okay? I do like this first step of find y prime. I think that's really important, okay? And we're finding y prime because it asks us about the slope, okay? So we're finding y prime because it asks us about the slope. And so if we go back to our original function and we use our power rule, we'll get y prime equals 2x minus 4 plus the 0, which I don't need to worry about, right? But I'm hearing a few different things in the chat. So some folks are saying plug in 1 for x. Some people are saying solve for x. So what do we think is maybe a better, or what do we think is a good way to summarize that? What are we doing with this 1 here? Yeah, we're going to substitute for x. So we can say sub x equals 1. Okay. And the x equals 1 just comes from the point that they're asking us for. All right. And so we're going to sub in x equals 1. I've seen some people write this as like, oh, y prime of 1, like you're plugging 1 in. That's another way to do that. So 2 times 1 minus 4, and we get y prime equals -2. Okay. And so what we found is the slope of the tangent line at x equals 1. All right. In fact, let's write that down. This is the slope of the tangent line at x equals 1. Okay. And so let's go back to our graph for a moment. All right. If we go back to our graph for a moment, it turns out that this vertex is at 2, 2. Okay, I wouldn't expect you to know that. It's just handy for us in this context. But if I think about where the point x equals 1 is, it looks to be about right over here. And I think we can see from that that the tangent line would have a negative slope. And that's really good because we got a -2 out, right? So what we expect it to be actually happens with what matches what happens. Okay. All right. So I told you that the x coordinate is 1. How can I find the y coordinate of that point? Okay, okay. So we've got some words to describe it. We're going to plug 1 into the original function. And we also have that procedure, thank you, Vince, where he's actually putting 1 into the equation. So we could say y of 1 equals 1 squared minus 4 times 1 plus 6. So 1 minus 4 is -3, plus 3 is 6, plus 6 is 3. Okay, so in particular, this coordinate is 1, 3. Okay, so we've got 1, 3 here. Now, if we look at part C and D, okay, part C and D are asking us to write equations of the line tangent and equations of the line normal. Okay, so let's clarify the difference between these two. So a tangent line follows the curve and touches the curve in that one place. In contrast, the normal line, okay, the normal line, all that is, it is the normal line is perpendicular to the tangent line. Okay, the normal line is perpendicular to the tangent line. We got a slope of -2 for this tangent line. What's the slope of the normal line going to be? Ooh, 1/2. Okay, because we took the reciprocal, which is 1/2, and we changed the sign. So it's not -2 anymore, but it's a positive 1/2. Okay, well, let's try a couple other examples. What if I told you that the slope of the tangent line was 5? What would the slope of the normal line be? Good, good, good. So if slope of tangent line is 5, then the slope of the normal line is -1/5. Perfect. Okay. If the slope of the tangent line is -1/pi, what is the slope of the normal line? Good, good. It's going to be pi. Okay. And how do we know that? We can see here that the normal line is perpendicular to the tangent line. Okay. So it's a line that is perpendicular to the tangent line. All right. So when we're writing these equations, I want us to write them in a very specific form. Okay. When you write the equation of a line tangent or a line normal, we're going to use what we call the point slope form. So we're going to plug it into y minus y1 equals m parentheses x minus x1. Okay. Let's see, there's a couple questions in the chat. In that case, we would need to know the vertex of the parabola or another set of coordinates. No, actually, we have all of the information we need right here. Okay, so the reason why we're using point slope instead of y equals mx plus b is because look at what we found already. We found the slope. right? So everywhere I see an M, I can actually put -2. And we have a point, 1,3. So we're going to take that point, we're going to plug it in for x1, y1. And then we're going to take the slope that we found and we're going to plug that in for m. Okay. So the beauty of this, you don't need to know the y-intercept. Okay. In fact, when they tell you where the slope, where they want you to find the slope, they're already giving you the x1. All you have to do is find the y1, and then you've got all the pieces that you need. Okay. So what are we going to plug in? Y minus 3, because that's the y1 value, equals, instead of m, I'm going to put -2 and then x minus 1. So we've got our x1 and our y1, and then we've got our first derivative telling us what that slope is. Exactly. Y minus 3 equals -2 parentheses x minus 1. Okay. I'm going to say this next part like 4 times. Do not simplify. Okay. I do not want you to simplify. I've seen students write this out and then they distribute wrong and then they get the wrong answer. And that really sucks. Okay. So don't distribute, because what if you make a mistake on a test? Okay. Second of all, this is so much easier for me to check. Did you plug the numbers into the right place? And that's what I'm concerned about. Okay. So leave it like that. You don't need to simplify anything. Point slope form is what we're looking for. Okay. The other reason why I want us to use point slope form is because it is so easy to find the normal line equation from the tangent line. The only thing we need to change is that slope. Okay. The only thing we need to change is the slope, because the normal line goes through the same point. All right. So our x1 and y1 are still going to be the same. It's just that we're changing the slope to be the negative reciprocal of our tangent line. And so all we need to do is y minus 3 equals, you all told me earlier correctly that the slope is not -1/2 or -2, but it's going to be a +1/2 x minus 1. And there we have our normal line equation and our tangent line equation. Okay, so the only thing that changes, the slope changed from -2 to a +1/2 because of that perpendicular nature. Okay. Last step, of course, is we're gonna draw some pictures about what that looks like, right? Just to really root it in our brains, like what are we finding equations for? So I'm gonna cheat a little bit. I'm gonna grab this picture, copy and paste it. Whoop. We're gonna put that right over here. We'll put another one right over here. Okay, so we've got our graphs. If I want to draw the equation of or if I want to draw the tangent line, all I'm going to do is draw a line that touches the curve in one place, sort of follows the slope of the curve. Exactly. Follows the curve of the graph, touches the curve at 1, 0. Exactly. Okay. Then if I want to draw the normal line, all I'm going to do is go through the same point, but is going to be going at a 90-degree angle to that tangent line. Okay, so we've got our tangent line and we've got our normal line. Okay, let's get that all on one page for folks to see, but we've walked through this process of sketching a graph, finding that slope, writing the equations, and then graphing our final picture at the end. Okay. Are there any questions about this logic and reasoning that we just went through?
I don't have a question, but if you could hang on this page for 1 second.
Mm-hmm.
I'm good.
Okay, cool. All right, would it be helpful for folks to see one more example? How are we feeling? We good? We want another example? One more? Okay. All right, so let's go ahead and take a look at a similar process, but with a different function. Okay, so similar process, different function, and then we'll take our break. All right, so given the curve 2 over x minus 3 over x squared, we're going to walk through graphing the function, finding the slope, writing the tangent line equation, the normal line equation, and then we're going to finish by drawing what we found on the 2 graphs below. Okay. So we have that 2 over x minus 3 over x squared. I would never expect you to know what this looks like, all right? Which is why in the notes it says use Desmos to find it. But this actually has 2 branches. One is over here, and then this one on the right-hand side kind of comes up and then down like that. Okay, this is a very rough sketch. Look at it on an exam, I would give you a picture because I would want you to focus on all the other pieces of this. But for some of the quizzes, I may ask you to graph it using Desmos, okay? All right, now let's take a look at part B. Part B says find the slope of the function at x equals 1. So exact same directions as the previous question. What do we want to do first in terms of setting up to find this slope? Rewriting that function. All right. So we have this f of x. And it's got 2 over x minus 3 over x squared. It's a little hard to use any of the rules we know. So maybe if we write it as 2x to the negative 1 minus 3x to the negative 2, that actually makes it a little bit easier because we're going to be finding that derivative, right? Now, I know we're in calculus class, so of course it makes sense to find a derivative, but what word in the problem tells us that we need to find a derivative?
Slope.
Yeah, that word slope, right? So we see that word slope and we're thinking find f prime of x. All right, I'll give you a moment to find that derivative. All right, so always good to practice finding that derivative. Make sure you got those rules. I believe the first term ends up being negative 2x to the negative 2. Yeah, we got to be so careful about that sign. I know. And I'm actually really glad that you put yourself out there and made that common misconception, because when we're subtracting, right, -1 minus 1 gives us -2. And I know you folks know that, right? Which is why a lot of times I'll tell students to write out like -1 minus 1 or whatever that power is, just to prevent those mistakes. Okay, so we get -2x to the -2 plus 6x to the -3. Perfect. That matches what we have in the chat there. So we found our f prime, and then what are we going to do? Yeah. Sub in x equals 1. Now, we've done 2 problems where it says plug in 1. But we're only plugging in 1 because the problem says plug in 1, right? If this said, find the slope of the function at x equals 10, I would expect you to plug in 10, not 1. Okay, so it's not that we're always plugging in 1, but we are plugging in whatever that question tells us to. And once we do that, f prime of 1 gives us -2 times 1 to the -2 plus 6 times 1 to the -3. We might notice that that's like a little hard to calculate in our brains. I think it's not too bad because we have ones here, but you know what might make our lives easier if we rewrite it using positive exponents. Okay, and so I would encourage us at this point to maybe rewrite the function so that it's easier to plug numbers into. And when we work through those calculations, we'll get -2 plus 4, plus 6, which will give us 4. Okay. So before we move any further, what does that 4 mean? Like, we got a number, that's great, but what does that 4 mean? Yes, the slope of the tangent line when x equals 4, or x equals 1 is 4. So the slope of the tangent line at x equals 1 is 4. Okay. And so, folks, by putting your sort of summaries and your answers to the questions in the chat, you're actually doing a really great job of preparing yourself for, let's say I ask you to explain your reasoning on something, right? So that's part of why I ask these questions in class. You don't necessarily have to type things out, but I think that if you are like, it's really hard for me to explain my thinking, reading what other people are writing might actually be very helpful, okay? All right, now, so we've graphed it, we found the slope. Now we have to write the equations of the line tangent and the line normal, okay? So we've got our tangent line, we've got our normal line. And we know that when we see these, I'm asking for us to write it in point slope form. And the only thing I'm going to change between the two of them is going to be the slope. I'm going to have the negative reciprocal over here for the normal line, okay? I see a couple questions in the chat. Is that because the tangent only touches at one point? Yes, indeed. So Catherine, that one point is where we are sort of finding the slope at that point. And so that's why we can use that point as our x1 and our y1. Okay. And so yes, Sophia, you are correct. We need to find y when x equals 1. So how do we find that? We take our function, we plug in 1. We compute some things. And we find that we're going to get a point right about here of +1, -1. Okay. All right. Take a moment, plug in the appropriate information into this equation for the tangent line. Go ahead and type that into the chat. You can either send it out to the whole group or you can send it directly to me, but go ahead and write out what your equation might be for the tangent line. All right, I see some great answers here. And for those of you who are like, how did that become a +1, like y +1? If you were not to simplify it, you would have y minus -1, -1 because that was the y value I got from above, which equals 4 because that's my slope from earlier, x minus 1. Okay. If you leave it like this, that's fine. If the one simplification you do is turn that left-hand side into y +1, that is also fine. But don't do anything else, just leave it like this so that you make your job much easier to write that normal line equation, okay? Everything is gonna stay the same, except instead of a slope of 4, -1/4, okay? Vince, can you be a little bit more specific about the y prime equals -1/m? What about that is tricky? What it means? Our negative reciprocal for like when we have perpendicular lines? Is that what you mean? Yes, okay. So that's just our way of saying negative reciprocal. So we're changing the sign, which is why we put the negative, and then reciprocal is just 1/. Okay. All right, great. Definitely cheating over here with the technology, but we can use this to help us figure out our tangent lines and our normal line picture, okay? And so all we're gonna do to sketch that tangent line, once we have that point, we can go ahead and draw a line that just touches the curve in one place, but it follows the shape of the curve. Whereas for the normal line, like Lucas says, the slope of the normal line is perpendicular. So we're going to draw something that goes 90 degrees from our tangent line, okay? And so visually, we've got a tangent line going this way, but a normal line kind of going that way. And because those are perpendicular, that is why we have a number, and then it's negative reciprocal, okay? So let me get this all on one page here for you. And let's see, before we take our break, are there any questions that are still lingering for us? Okay, well, we might think of some other questions during our break, but let's do this. I feel like I've been really bad about the timing and it's been really tough to get that second break in. So maybe we take a 15-minute break right now. All right, so a little bit of a longer one, but then we'll come back and sort of be able to finish the rest of class. Okay, so it is 8:10 right now. So let's say 8:25 a.m. Back at 8:25 a.m. All right, and then when we come back, I think it would probably be a good idea to take a few questions on the trig Desmos activity, and then we'll move into 3.4. Okay, so I'll see you folks back here in about 15 minutes.